The purpose of this video is to show you a couple of things. One, how do you tell others about your functions in such a manner that they don't have to look at your code? And number two, how can you extract that information from Python's standard functions? So let's begin by creating a function. We'll go back to our old friend square because we fully understand what's happening here. Okay, and we say return x star x. Now what I'm going to do is on the first line of square, I'm going to put a triple quoted string. And I'm going to fully describe the behavior of this function. So what are the things we need to worry about when we describe the behavior of function? Let's talk about that first. Okay, first of all, what type should the parameters be? All right, here in this case, x should be a number, right? Secondly, what should be true before the function is called? Now, you might even take the second line here and describe it in the answer to the first question. Then the next thing is, what are the side effects of this function? Okay, possibly none, all right, or possibly something. Okay, what is the return value? These are real things that a user of your function is going to want to know. And in this, you can describe the function's action. And again, here, this also describes the function's action. Because what the user of your function is going to want to know is he's going to want to know what does the function do and when can I call it. Those are the important factors. So we do things in this fashion. This is a very common way to do things. You create something called a precondition. All right, what is true before the function is called? And the precondition we have here is x is a number. All right, so it could be, you could use this function, it turns out, on integers, floating point numbers, or complex numbers, any of those. So if x is a number, all right, there it is. That's your precondition. Okay. Anything else we need to be true? No, not really. Okay, that's all that's needed is a value needs to be a number. So that is the precondition, the condition before the function is called. Postcondition. All right, what are the postconditions? Well, there is no side effect, and the square of x is returned. Okay, and that pretty much describes exactly what that function does. Now, how do I see the result that I've created? How does my user find out about this? Well, he can do something like this: print square dot double underscore doc double underscore. Okay, print that out. So this is going to give me information on that function. And see, now you have described in a very concise way what that function does. It says x is a number, there's no side effect, and the square of x is returned. Okay, so this, when you're writing a documentation for a function, you want to be direct, simple, but complete. Okay, and this is nice and complete. So if you are writing functions that others are going to land up using, and this is very common in a collaborative environment, creating this kind of documentation is useful. Now, the second thing you might ask is, can I do this to a standard library function? Let's do len dot double underscore doc double underscore. Let's see what that says. Ooh, look at that. Returns the number of items in a container. So when you are puzzled about a function or when you want to know about a function, you can always appeal to its docstring, and it will give you a brief summary of what it does. Here, let's try doing this. Okay, input. Input is a function. Let's see what it does. It is one of Python's global things. It says, the prompt string, if given, is printed to standard output without a trailing new line. Ooh, sorry about that. If the user hits EOF, Control D, or Windows Control Z, it'll raise some kind of an error. On Unix system, read line is used if available. So what it does is it gets a string off the screen and stores it in a variable if you assign input to a variable. And here I'll just demonstrate that real quick. You want your program to be interactive. Watch this. I'm going to say, okay, so the argument is a string. Now, the catch with input is things come back as strings. So whatever the person types is going to be in a string. So what am I going to do with that? I'm going to do this. All right. Okay. Enter. In fact, let me be specific here. Enter an integer to square. Okay. N is equal to int of s. And then down here, I'm just going to say print format string f of curly brace n is equal to, not f, square. I get f on the brain there sometimes. And then curly brace square of n. All right. All right. Now, let's go ahead and run this program and see what it looks like. It says enter an integer to square. You know, I should have put a space after my prompt because it doesn't look right. But let's put in 5, and it says square of 5 is 25. Hey, not so bad. Now let me go ahead and get rid of these lines because I don't need to see them anymore. We've seen what they've done. And I'm just going to go ahead and hide them with a comment. Okay, bingo. All right, now you might ask, what if the imbecile who is using my brilliant code decides to put in something stupid? Okay, let's see what happens. I'm going to put in cow pie. Moo! Ooh, it says trace back, value error. That's the type of error that is seen. All right. Well, if you want to prevent that from happening, you can do the following. You have code that has peril attached to it. Try it. Now, we know that this will give us a value error. So I'm try and accept their 2 new boss statements. You're learning right now. All right. So try this. All right. Now, in the event that we get a value error, let's just print something like enter an integer. Imbecile. All right, yeah, let's be saucy, and we'll just quit out if they do that. Okay, so this is called handling an error. And the reason we use this try except block here is because this is something beyond our control. This is called exception handling, and I will sort of introduce it on the installment plan as we go along. In fact, let's do this while we're at it. Let's go ahead and run this twice just to see that it does what we want it to do. Okay, I'm entering an integer to square 10. All right, now I'm going to do it again. I'm going to enter cowpie, and the program simply quits, and that's probably what you want it to do because the user did something that makes absolutely no sense at all. Let's go ahead and fix this, incidentally. If you're going to make a prompt like this, probably good style is I like to put a colon at the end and then 2 spaces just to sort of set things off visually. But now you know about docstrings, and the one other docstring I want to print out here is let's print int dot double underscore doc double underscore. Let's see if by any chance, okay, I'm going to enter my number to square 10. All right. Convert a number or string to an integer, or return 0 if no arguments are given. If x is a number, return int of x. For floating point numbers, this truncates towards 0. If x is not a number, if a base is not given, then x must be string, bytes, or a byte array, blah, 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 blah. All right. The base defaults to 10. Okay. Interesting. What it doesn't tell us is, and should tell us, is if somebody erroneously enters something that's not sensical, it should tell us it throws a value error, which it does not do. I'm kind of disappointed in that. But c'est la vie, but at least we know that. Okay, so when you try to cast something to an integer, it's not a bad idea to put it in a try block if it's something that's entered by a user. If it's something that a programmer should know better about, well, then, yeah, let him have the pie in the face and let his program die on the spot. So this is the docstring. The docstring has 2 uses. One, if you create interesting, useful functions and want to use them later, you want to create a docstring like this that describes what the function does, so you don't have to go back through the code and try to figure out what it does. You simply read that docstring and you know. And your colleagues who might be using your little library of functions, they also will know. Secondly, you've now learned that you can get help. You can get the docstring by taking a function, a standard library function, and doing the double underscore doc thing, and you can see what kind of docstring was written for that function. All the standard library functions have these. So that's docstrings and preconditions and postconditions.